Okay, so example 3. It says here we have a 10-meter derrick. Okay, and I'm going to show you a picture very shortly of what this looks like. It's supported by a span 6 meters long attached to a vertical mast at the point 8 meters above the heel of the derrick. Find the forces in the derrick and the span when the load of 4.5 tons is hanging vertically from the derrick head. Okay, so they give us this little drawing here, but I want to show you the way I've done it. Okay, so first of all, they say in the question, they say, okay, so this is what a derrick looks like. You find these on a ship, so it's a crane. Like normally you see on land, you'll see a crane. It's got it's standing straight up, and it's crossed like that. But for a derrick crane, it's using a mast, and this is called the derrick head. So that's the derrick head, and then on the top here, the span, there's some steel wire ropes coming through the top here. So for this problem, and obviously on the hook there, that's where the load's hanging. Okay, so where is the mast? Here's the mast on the side here, and they tell us in the question that the mast is 8 meters long. So 8 meters or 8 meters high. Okay, and this is the mast, like that. Okay, and then the span. Where's the span? So this is the span here. Okay, so the span, and they tell us that the span is 6 meters, right? And then the derrick head, the derrick head, the derrick head is this here. So this rigid structure here is the derrick, and that's 10 meters. And then over here is where the load is hanging. So we have a load of 4.5 tons. 4.5 tons. Okay, so we're going to translate this now into our drawing. Okay, so I've done that already. So you can see over here. So let me try and see if I can get both in here. On the top here is the span, the 6 meter span. On the side here is the mast, the 8 meter mast. And over here diagonally is the derrick head, which is 10 meters. And in red here is the load of 4.5 tons. All right, so there's my my space diagram, and then I'm going to now, just like always, I'm going to take the vector that I know of the force in. So over here, the load, I know that the force here is 4.5 tons. They told us that. All right, so I'm going to have to draw that to some scale. In this case, it's quite easy. 4.5 tons. So I'm going to say, for my force triangle, I'm going to say 1 ton equals 10 millimeters, or 1 centimeter. So I'm going to draw that. So I've already done it faintly here, but you can see. So we're gonna, if it's 1 ton equals 10 millimeters, then obviously it's gonna be 45 millimeters, or 4.5 centimeters. So let me draw that in red here. Scale. All right, so there's my load. Okay, 4.5 tons, and that's obviously 45 millimeters long. All right, and then just like always, we're going to translate or transfer these ones now that we want to find the forces in parallel down. So I'm going to need my triangle. Okay, so first of all, the span. So let's do the span first. So we're going to go, over here now, we're going to go there and then there. Okay, so let's do the span. So we're going to line that up. And yeah, I've got it lined up there, and I'm going to move this one down. So let's move it down, and there I move it down to there, so it's in parallel. Okay, and then I'm going to draw a line. Okay, so I've already done it darker there for you, so you can see it. And then the derrick head. Let's see the derrick head. So there it's lined up, you can see, and I'm going to move that down to here like that. Okay, so that's in parallel. And again, I'm going to draw a faint line, and where the two intersect, which is that point there, that's the end of the line. So let's draw that in, and there we go. So there's my force triangle. So I've got my load. This here is the span, and this is the derrick. Okay, and again, all I need to do is measure them. So if I measure the span, sorry, I'm out of camera there. If I measure the span, that's going to be 34 millimeters. So I got 34 millimeters here. Am I just right? Am I right? Let me check that. 34 millimeters divided by 10 millimeters, and then I'm going to get obviously 3,4 tons of force. Okay, so in the span up here in the span, there's 3,4 tons of force. And in the derrick head, let's see what's in there. So I measure that. That's gonna give me 56 millimeters. 56 millimeters. And I'm gonna divide that by 10 millimeters, and I'm gonna get 5,6 tons of force. All right, so very simple problem. The only thing you needed to know was what a derrick looks like, and then it's quite easy. So you need to know what the span is, what the derrick head is, what the mast is, and the load. So yeah, hope that helps.